Hi guys, so this is for Unit 2's study guide. All right, so there's a couple things we got to start off with here. We have to start off with talking about relations. Now, in number one, they go ahead and tell us that the relation represents the number of items you purchase and the cost. And basically, we have our inputs, otherwise known as our x's, and our outputs, otherwise known as y's. Okay, and these are ordered pairs. So 0, comma 0, that's an ordered pair. Now, first things first, part A says we have to write the domain in set notation. So we have our domain, all right, in set notation. That means we have to identify all our inputs, okay? So all our independent variables. So we have 0, 1, 3, 5, and 8. So we list them here in what we call set notation. Now we have to describe what the domain represents in this situation. In this situation, domain represents the number of items. Okay, the number of items that we purchase. Make sure you use the full complete sentence. That way you can make sure you get all your points. Now, part B is describing the range. And again, we're using set notation. So similar to part A, except instead of focusing on our x's, we're focused now on our y's, our outputs, okay, our dependent variables. So that's a terrible bracket. I apologize. There we go, a little bit better. Our first output or y value was 0. Our second was 5. Our third output was 8. And then we had 11 and then 16. Now, what does the range represent in this situation? The range represents the cost. Okay, and let's go ahead and assume the dollars. All right. Now, if we were to graph the following situation, well, first things first, our first ordered pair is at 0, comma 0. So we're going to go ahead and plot that 0, comma 0. Our next ordered pair is 1, comma 5. So we're going to go to 1, comma 5. Okay. And our third ordered pair was 3, comma 8. So we're going to go to 3, comma 8. And then 5, comma 11. And I'm just going off by the ordered pairs 5, comma 11 for our relation. And last but not least, 8, comma 16. So 8, comma 16. Now, first things first, is this going to be discrete or continuous? So what I want you guys to do, and this is for you, for your homework, I want you to explain the difference between continuous and discrete, okay? So go ahead and write continuous is blah, blah, blah because of blah, 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 and discrete is blah, 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 blah. So to try to describe it, look back at your notes. I will give you a hint. In this following situation from part C, there are no lines, there are no curves, they're all independent, isolated dots or points. On this example right here is discrete. Okay, so try number or part D on your own. Okay. All right, number 2, the following sequence is defined by this explicit rule. What is the common difference? Well, the common difference usually is coefficient right before our variable, okay, which is n. So our common difference here is, well, d equals 9, okay? Now we're going to prove this by writing the first 3 terms of the sequence that is given to us. We're using the table. So our first term, okay, is basically just saying, well, what if n is 1? Well, f of 1 would be, and again, I'm referring back to the explicit rule here, 9 times n, and n has to be 1 this time because our first term, plus 1. Well, 9 times 1 is just 9, and 9 plus 1 is 10. So f of 1 is really just going to equal 10. So your first term will be 10. Now, your second term, known as f of 2, will look like this. You have 9 times n, which n in this situation is 2, plus 1. You should get 18 plus 1. So f of 2 equals 19. Now, if you remember common difference, you should be able to see it here on the table. And you should be able to get the pattern to work for you to finish your table. Okay, so that's something to acknowledge. If your teacher prefers you doing function notation to double check, that is perfect. In fact, I would definitely recommend doing that in the first place. All right, number 3. So we have a same situation. We have an explicit rule that's given to us. Same kind of question for part C. Sorry, that's apparently part A. I'll change that eventually when I get to it. But it's just like number 2. Okay, so look at what I did number 2, and I want you to try number 3 on your own. Same thing with number 4 on your own, okay? Same stuff, just different rules, okay? Different differences, and of course, different first 3 terms. All right, starting off with the new concept is the recursive rule. And we're going to write the recursive rule for the following sequence. 2, 4, 6, 8. Who do we appreciate? All right, so our first term. Now, when we write the recursive rule, there are some things we have to notice. First things first, what's our first term? First term here is 2. Okay, now to write the recursive rule, the rest of it, we have the function of n. Okay, again, that's our term number, or our nth term, equals f of n minus 1, which is a fancy way of saying the last term that we're working with. Now, what is our common difference? We had 2, now we go up to 4, so that's plus 2. We had 4, now we're going up to 6, that's another plus 2. So it looks like our common difference here is 2. So plus d, which is really just plus 2. So again, that's how it's set up. But in your answer, let me go ahead and erase this real quick. There we go. Is just going to be 2, okay, which is your difference. All right, number 6 and number 7 are just like number 5. Okay, so go ahead and try, get some practice, and write the recursive rule. All right, number 8, is the following relation a function or not? Explain in a full complete sentence. That, ladies and gentlemen, is worth points. Okay, we care about your reasoning. More so than the answers sometimes, or at least most of the times. All right, so first things first, let's look at our inputs, or our x's, okay, and to our outs. So as you can see, -1 goes to 5. That's a 1-to-1 relationship. 0 to 3 is 1-to-1. And 1 goes to 5. That is also 1-to-1. When I'm saying 1-to-1, I mean there's 1 input to 1 output, okay? 1-to-1. 2 goes to 11, and 3 goes to 21. So it looks like, yes, this is a function. And I would say yes, since for every 1 input, comma, I have exactly 1 output. And you could also do the whole 1 to 1. Okay, so that's exactly what is expected of you. If your teacher wants more, of course, compliment that, and maybe your teacher is doing a better job. Who knows? They're great. Okay, so let's check out number 9. Now, I want you guys to work on this together for homework. Remember, you want a 1 to 1. If it's not 1 to 1, okay, if it's 1 to 2 or 1 to 3, it's not a function, okay? So I want you to go ahead and try number 9 out for yourselves and see if it's a 1 to 1, okay? So again, you should have one input going to one output, okay? So if you press option 1 on a soda machine, you shouldn't be getting a Pepsi and a Sprite. Okay, that is not functioning. That machine is broken. This is actually a 1 to 2 relationship. This is not a function. Okay, so that is just an example. All right, so number 10. This one's worth a lot of points. Draw the following graph for the given situation. So we have distance and minutes. First things first is we left our house, okay? We are running 3 miles in 20 minutes. I'm going to call that part A or segment A. So we're going to go up to 20 minutes. In 20 minutes, we ran 3 miles. So we're going to be at 20, comma 3. Now, of course, we start here at home, right? And we're running. I'm sorry, we're actually going this way. We're going the other way. We're running. Oh, 3 miles. Then something happens. We took a nap, 20-minute nap. So that's part B. So again, here's part A. Now segment B, 20-minute nap. So for 20 minutes, notice the units here go by tens, okay? We took a 20-minute nap. Now, why is it a flat line? Why do we have a constant right there? And it's because we're not changing distance. You're not moving during your nap, okay? It doesn't say that we covered any distance, okay? So it's just a flat line. Now, we walked 1 mile for 10 minutes. So for 10 minutes, we walked 1 mile. So 40 plus 10 is 50 and 1 mile. Okay, and again, that is part C. And then we stopped to watch a bird for 20 minutes. Don't ask me, man. I'm not judging. You do whatever you want to do when you run. Watching a bird, nothing wrong with that. So 50 plus 20 is 70. Notice how we're not going anywhere because again, we stopped. We're not covering distance. All right, then we started walking back home for 40 minutes. So 70 plus 40 is 110. So here we are coming back, closing our distance. And there we go. That will be part E. Okay, so that's what I want. I want you to also label your segments. That way you understand what is what, okay? So you really have to break down the wording. You're interpreting the given relation between minutes and distance, and you're plotting it and graphing it. Okay, so number 11. It's just like number 10, okay? But the story, the situation is different, okay? It's not going to be the same graph. So go ahead and try it with your group. Go by each little bit that they have here, okay? So think about what segments are what. All right, number 12. Bob opened a bank account with $140. He deposits $10 every month. Use function notation to write a function that shows the amount in Bob's account after m months, okay? So we have a function of months, okay? So a function of m equals, well, we have $10 every month, okay? Plus the 140 that he threw in at the very beginning. So this is what we call function notation in this context, in this situation. We're worried about months. All right, so that's the function. Now, part B, how many months will Bob have $400 in his bank account? So we're going to use the same function from part A, okay? So let's see. He's going to have, and this is really just f of m, okay? That's his output. So we're going to have 10m plus the 140. Okay, that function equaling 400 bucks. Okay, so we're just going to solve for m. If we do this real quick, let me do that correctly. There we go. That should be 260 and equaling 10m. Notice I'm using the subtraction property and eventually the division property, just like what we learned previously in Unit 1. It's all connected, okay? And then finally, m equals 26. So leave your response in a complete sentence, though. So yes, you can box this, but you got to get the full points. So let's write this in a sentence, okay? So you're going to say, in 26 months, comma, Bob, sorry, capital B, Bob. All right, Bob will have $400 in his bank account. Good old English. All right, don't ignore it. Words matter too. So in reality, this is the answer. All right, so go ahead and try number 13. Different person, same situation, just different numbers. Okay, I think that's 500 and 100 every month. So again, you're going to set up function notation, and then you're going to solve to figure out how many months for part B. Okay, so number 13 is homework. Okay, work on that with a friend. Number 14 is very similar to the Bob situation and the Bailey situation from number 13. That too is also homework. Okay, same ideas, just different numbers. Okay, guys, so that sums up the study guide. If you have any questions, let me know. And best of luck, and please, please, please study. All right, take care.